Hello everyone, welcome to Think Then Code. Today we'll be solving the problem Count Palindromic Subsequences which appeared in the Biweekly contest. So let's try to understand the problem. Given a string of digits s, return the number of palindromic subsequences of s having length phi. Since the answer may be very large, return it to 10 to the power 9 plus 7 modulo. A note, a string is palindromic, it reads backward and forward, it's common. A subsequence is a string that can be derived from, that's also common. So let's try to understand what the test cases says. We are given a string s which only contains digit, and the output says there are only two palindromic subsequence of length phi. So we can also see that this is first, that is 1 0 and 3 1 0. This is the first palindromic subsequence, and the next is this 1 0 3 and this 0 1. So what are the constraints? The constraints are this has to be done. Okay, 10 to the power 4 are the constraints. So what the problem says is we are given a string s and we have to count the palindrome subsequences of 5 length, and s only contains digits. So let's try to understand what can we take some observations from it, and then we will go forward with the algo. The first observation here is the length of the palindrome should only be 5 digit. So if we consider a palindrome, let's say this is a 5 length palindrome. So in the 5 length palindrome, it doesn't matter whatever appears in the middle. Only things matter is this. Why? For example, let me place here A and let me place here B. So to make this palindrome, here I have to place B and here I have to place A, because that's the definition of palindrome. And in this middle position, I can place anything, like it can be A to Z, anything I can place, A to Z or any 0 to 9 number. So this is the first observation about the palindrome. The second observation is digits. So if we are considering a 5 length palindrome and everything is a digit inside it, so since we know that this thing can be anything from 0 to 9, and if we fix this part of the palindrome, this part can be obtained because it's just the reverse. For example, 0 1 7 1 0 is one 5 length palindrome. This is the middle part and this part is the reverse of this part. So if we know the left part, we can get the right part. So if we see this left part of things, there are only 2 characters because it's 5 length palindrome. So in 2 characters, how much combinations we can have? Here we can put numbers from 0 to 9, and here also we can put numbers from 0 to 9. So basically the total number of combinations will only be 10 into 10, that is 100. So there will only be possible 100 digits which can be put here. This is the second observation, and this will be quite fruitful when we move forward with this problem. So let's try to understand what the algo is. This is a brief overview of the algo. So basically, suppose there is a string s and we start traversing the string from left to right. Okay, so we are traversing from left to right. We have an I pointer, and suppose the I pointer is currently at 3. Let's suppose the I pointer is currently at this 3. So if the I pointer is currently at 3, we fix that the middle element of the palindrome will be this 3, which means that we are looping every element and fixing the middle part of the palindrome. that is, if this is the file and palindrome, this part is fixed from here. So if this part is fixed, basically now the left part will come from here and the right part will come from here. So what we will do is we will store every 2-digit subsequence of the left part. For example, 0, 1. What will be the count of 0, 1? The count of 0, 1 will be 1. The count of 0, 3 will also be 1. And the count of 1, 3 will be 1. So basically we will store all 2-digit subsequences from the left side of our pointer and store their counts. And the same thing we will do in the right side also. So to the right of A, we have 0, 0. This is having count of 1. And we have 0, 1. This is having count of 2. That is, this 0, 1 can be one subsequence. And this 0, 1 can be second subsequence. So we have here count of 2. So our I pointer is here. What we will do is, from the left part, we will traverse each subsequence. Yes, we will traverse each subsequence. And since it's a 2-digit subsequence, the max number of these subsequences can only be 100. So we will traverse, suppose we are traversing 0, 1. We will reverse 0, 1, that is 1, 0. And we will check whether 1, 0 is present here or not. Right, in the right side of the thing. Since 1, 0 is not present, we cannot make it. So we'll check for 0, 3. Is 3, 0 present? 3, 0 is also not present, so we cannot make it. And we will check 1, 3. So 3, 1 is not present, 3, 1 is also not present, so we cannot make it. So if it would not have been, instead let's assume it to be, let's assume to be 1, 0. If it would have been 1, 0, then our left side subsequences would be 1, 0 having count of 1, 1, 3 having count of 1, and 0, 3 having count of 1. So in this, if we see for this subsequence 1, 0, our reverse is present 0, 1. So if we are fixing this 3 here, and 1, 0 is having count of 1 and 0, 1 is having count of 2, so what we will do is we will add to our answer 1 into 2, because 1 from 0, 1 side and 2 from 1 from 1, 0 side and 2 from 0, 1 side. So basically we will add 2 to our answer. So that's how we will move. But one challenge is how we will build these tables on the go. We don't want to perform extra thing. The only thing is we have to build this on the go. So let's try to understand how we will build this on the go. Let's assume this is 1, 0, 3 and this is 3. So our current pointer is that this 3. So how we will build this? We will store the number of occurrences for each character here. For example, 0 occur one time, 1 occur once, and 3 occur once. So this table will be at max 10 length. And since we are currently at 3, we will travel each and every character and go to the subsequence to it. For example, 0, 3 will form a 0, 3 digit, 1, 3 will form a 1, 3, and with 3 it will form 3, 3. So we will increment the count of these all subsequences in this table. So that's how we are going to create this table on the go. So since we are able to create this left table, what about this right table? So for right table, we are doing just the reverse of left table. So in the left table, we are increasing the count of the subsequences. In the right table, we are first creating the entire table by traversing from the end to the front. And as soon as we move with this I pointer, we keep decrementing this table. How? We will understand in the dry run of this thing. So let's understand the dry run. I have taken the string s as 1221122. So the first thing we have to do in it is to fill this sub back array. So I have taken these variables. First is the forward counter. It will be used when we start traversing from left to right. It's the size of 10 and everything is stored 0. For simplicity, I have just taken 1 and 2 here as 0, 0. This is subsequence forward array. That is, it is of size 100 and it is stores like a count of every possible subsequence. Then we have subsequence backward array. It is also of size 100, which stores the count of every subsequence which is occurring to the right part. And then we have backward counter, which stores the count of the character from 0 to 9 on the right part of the pointer. So first we have to fill the sub back array. So we will start with the last 2. For 2, we check the backward counter. Since everything is 0, no subsequence can be formed. So we just change the count of 2 to 1 and then we move forward. Now we move to this 2. Since the count of 1 is 0, we cannot do anything. When since the count of 2 is 1, we can form a subsequence of 2, 2. So we will store 2, 2 here with a count of 1. And now this 2, the count of this 2 will be updated to 2. So the count of this 2 will be updated to 2. Now we move to 1. Since there is no subsequence. Since 2 is there, we will form a subsequence of 1, 2. And its count will be the count of the number which is in the backward counter. Since 2 occurs twice, the count of the subsequence of 1, 2 will be 2. And then we update the count of 1. So the count of 1 is updated to 1. Now we move to left. We have this one. Since this one has a count non-zero count of 1, so first subsequence will be 1, 1 having a count of 1, and next will be 1, 2 with a count of 2. Since 1, 2 already have a count of 2, we will increment it to 2 plus 2, that is 4. So the count of 1, 2 will become 4 here. And the last thing we have to do is to update our backward counter. So instead of 1 here, it will become 2. Then we move to next part. That is this 2. In the same way we are doing it, it will be 2, 1 having a count of 2. And since 2, 2 is already occurring, so we will change this. It will be 1 plus 2 here. So it will become 3. And then we update the count. So this 2 will become 3. Then we move to this 2. This is 2, 1 having count of 2. Since 2, 1 is already having count of 2, we erase this and make this count as 4. 2 plus 2 is 4. And since 2 plus 2 is having count of 3, we are currently having 2, 2 as count of 3. This 3 will be updated to 3 plus 3 means 6. And then finally we will update our count of 2, that is to 4 here. Then we will reach the 0th index. 1 1 having count of 2, this one will be updated to 1 plus 2, that is 3, and 1 2. So 1 2 is already having count of 4, so 4 4 it will be updated to 8. And then finally we will updating our counter from 2 to 3. So that's how the backward counter and sub back, that is subsequence backward, is being finished. So since we are done with it, now we have to traverse from left to right in our array, and in this way we will update our answer also. So let's keep an answer variable here just to keep updating. Now since we are moving first from left to right, we start from the 0th index. At every index from left to right, we have to perform three operations total. First, remove from back, abbreviated as RB. Second, add to answer. And the third is add to front, that is add to forward. So keeping these three operations in mind, first we start with 1. First we have to remove from back. So first what we will do is we will decrement the backward counter. So we will go to here, this 3 will be updated to 2. Now we will check what all the subsequences which are formed with this one. So this one will form 1 1 twice. So whenever we are having 1 1, we will decrement its count 3 minus 2, which will here will be 1, and 1 2 have count of 4. So this 8 will be updated to 4. Now we are done with our first operation, that is remove from back. Now we will do add to answer. In add to answer, what we are doing is we see every subsequences which is having a non-zero count in sub forward, that is subsequence forward. Since there is no right now no subsequence in subsequence forward, we cannot do anything. Then the third operation is add to forward. So add to forward is very simple operation. Since this is 1, in the same way we created the backward, we do forward. Since everything in the forward counter having count of 0, we cannot form any subsequences with it 1 right now. So we just update the counter. So this is updated to 1. Now we move to 2. First we remove from back, so the count of 2 from 4 is changed to 3, and 2 1 is having 2 as subsequence. So this 2 1 with 4 will be updated to 2, and 2 2 is having count of 3. So 2 2 of 6 here will be updated to 3, that is 6 minus 3 3. Since we have removed from back, we calculate answer. Since nothing is there in the subsequence forward, again we cannot do anything, but we will do the third operation. That is, since 1 is having a count of 1, there will be a subsequence of 1 2 having count of 1. Okay, so we have added the subsequence, and finally we update our counter from 0 to 1. We are on 2. First we remove from back, so we update the backward counter first. So this will be decremented by 1 from 3 to 2. Then we check our subsequences. 2 1 of subsequences having count of 2. So we will decrement this 2 1 by 2. So this will become 0. And 2 2 is having count of 2. Since what 3, it will become 3 minus 2, that is 1. We have removed from the back. Now we will add to answer. So since now in the subsequence forward we are having 1, that is 1 2, we will check whether the reverse of it, that is 2 1, is present in this subsequence backward or not. So it is present, but it is having count of 0. So we will not add anything to our answer. So this has been done. Then we add to forward. So to add to forward, first we check every count. So 1 is having count of 1. which means 1, 2 will be having count of 1. Since 1, 2 is already present, we increase this 1 and it becomes 2. So 2, 2 can also be formed with this 2 and this 2. So we make 2, 2 having count of 1 and we update our forward counter. Then we move to this 1. First we remove from the back. So the count of this 1 becomes 1 in the backward counter. Then we traverse the backward counter. 1, 1 having count of 1. So here 1, 1 was having count of 1. We make it 0. And 1, 2 having count of 2. Here it is 4. So we make it 4 minus 2. That is 2. Then we add to our answer. We check for all subsequences sub forward. 1, 2 is 2, 1 present. Yes, but its count is 0. So we cannot do anything. 2, 2. Yes, 2, 2 is having count of 2. Its reverse is 2, 2. It is also having count of 2. So finally, we add 1 into 1. That is 1 to our answer. And the subsequence formed in this case will be 2, 2, 1, 2, 2. This is the subsequence. Sorry. 2, 2, 1, 2, 2. 2, 2 from this and 2, 2 from this, and the 1 is the middle. So the first time we add the answer. Since we have added to the answer, now we update our forward counter and forward array. So first we check the forward counter. 1 is having count of 1. So we will add 1, 1 having count of 1. And 2, 1 is having count of 2. So we will add 2, 1 having count of 2. And then we update our forward counter. So this becomes 2. Now we go to the next part. This is 1. Update the backward counter. This 1 becomes 0. Traverse the entire backward counter. 1 counter is 0, but 2 counter is 2, which means 1, 2 will have count of 2. So we will decrement it. 1, 2 from 2 here becomes 0. Now we check our answer. 1, 2 here is reverse of it is present. 2, 1 is present but having count of 0. 2, 2 is reverse of 2, 2 present. Yes, reverse of 2, 2 is present and it is having count of 1. So again the palindrome which is formed is 2, 2, 1, 2, 2. So we again add 1 to our answer. Then we check for 1, 1. Is reverse of 1, 1 is present? Yes, it is present but having count of 0. So we don't do anything. 2, 1 is present of 2, 1, that is 1, 2 present. Yes, 1, 2 is present but it is having count of 0. So it doesn't add anything to our answer. Then finally we update our front. So 1, 1 having count of 2. So this 1 will be updated to 1 plus 2, that is 3. And 1, 2 having count of 2. So this 2 will be updated to 2 plus 2, that is 4. And we update our counter of 1 from 2 to 3. We again move left. We update the counter of 2 to 1. Only 2, 2 will be formed. So this becomes 0. We try to add it to the answer, but we cannot because everything in the sub bag is having count of 0. And then we add to front. So 1, 2 will be 4 plus 3, that is 7. And 2, 2 having count of 1. So it will be 1 plus 2, that is 3. And this 2 will be updated to 3. So that's the dry run of the case. Since everything in the sub bag is now having 0, so we cannot form the answer. So our final answer will be 1 plus 1, that is 2. I hope you understand this algorithm. Let's go through the code now. So let's look at the code. This is the accepted code. The type def long LL is just a short form from long which I am using in my entire code as LL. And this mod will be used to calculate our answer, as we have to return the answer with modulo of 10 to the power 9 plus 7. So the first thing we are having is give reverse. So whenever we encounter a subsequence in forward, we have to reverse it, because in the right part of the palindrome, the left part should be of its reverse. So that function does it. How is it does it is, if any number is less than 10, for example 0, 1, 0, 2, 0, 3, it just return 10 into x, because that's the reverse of it. And in this part, it is just swapping the units and tens place of the number. So x modulo 10 is the units place. It is multiplying it by 10, that is making the units digit to tens digit, and x divided by 10 is basically bringing the tens digit to the units part. So that's the give reverse. Then we are creating our variables which will be stored. This is the forward counter, as we discussed in the dry run, backward counter of size 10, subsequence forward, subsequence front having size of 100, and subsequence back. So first we are filling subsequence of back. So we start traversing the R array from backwards. We get what's our current digit. Then we traverse our backward counter. So if backward counter anything is having count of greater than 0, we update our subsequence back. So how we are updating our subsequence back is, first we are doing x into 10. So why we are doing x into 10? For example, we are currently at let's say it is 0, 1, 3 and 1. We are currently at this one, and our backward counter will be 0 having count of 1, 1 having count of 1, and 3 having count of 1. So this is our x, and the subsequence form will be 10 into x plus any j from this backward counter. For example, if we are forming 1 with 0, it will be 1 into 10 plus 0, that is 10. So that's what is going on here. We are multiplying x into 10 plus j and increasing the count by backward count of j, which means whatever be the count of the backward counter of this, the subsequence count will be updated accordingly. So this is subsequence backward, we are updating subsequent backward, and then we increment the backward counter. So that's how we are filling subsequence backward. Then we are created an answer variable. Now we start traversing from left to right. So since we saw, we have to basically perform 3 operations. First, we remove from back. Second, we calculate, that is add to answer. And the third is we add to front, that is add to front forward, subsequence forward and forward counter. So first, removing the back. This is just the reverse operation of adding to back. So in adding to back, what we were doing is we were having a for loop, and then we were updating backward counter. In the same way, first we are decrementing the backward counter, and then we are learning the for loop. Just that here we were doing addition, and here we are decrementing the subsequence backward. Then that's the part of calculation. We are traversing every subsequence front that is present, and we check if there is a subsequence backward present for the reverse of the subsequence front, then we add to our answer. So basically, if our subsequence front is currently j, which is a subsequence front, let's assume it is currently 35, and this 35 is having count of 2. So we will reverse this 35, that is 53, and we will check in back what is its count. So whatever be its count, let's assume it's 3. So we will add 3 into 2 into our answer. That's how that part is, the calculation part is working. We traverse every subsequence front and get the reverse of subsequence front, check the counts in subsequence back, and add to our answer. And that's the modulus operation, because the answer can go very high. And then the third operation is we are adding to front. So to add to front is very similar to adding to back. We are just traversing the forward counter. If the forward counter, any character is having count greater than 0, we update our forward counter. It's just that here it is 10 times into j plus x. Earlier it was 10 into x plus j. So why is 10 times x into j? Because when we are updating our forward, let's assume our forward counter is currently this 0, 1, 2. This is having count of 3, this is having count of 1, and this is having count of 2. So if we are having our current element x, which we are traversing, let's assume it is 2, and this is our j. So if this is forming, let's assume this is forming with 2 and 2. So obviously this will be 22, and 22 can be written as 10 into 2 plus 2. So this 2 came from here and this 2 came from here. That's what we are doing here. 10 into j plus x in subfront and incrementing its count by forward counter of j. Then we increment our forward counter. Since these three operations are done, we finally return the answer. I hope you got the code. Now let's understand the time and space complexity. So talking about the time complexity, basically in our code, what we are doing is, this is a big O of 1 operation, so this doesn't contribute to it. We are creating an array of 10 and 100 sizes, and then we are just traversing our entire string twice. So the time complexity will be big O of n into 100. Even though we don't consider constants, but since 100 is quite a big number, I am just adding here. Though its time complexity will be big O of n. Let's talk about the space. When we are talking in the parts of space, we are only creating these vectors, and these all are having constant size 10, 10, 100, 100. So basically we are not creating anything which is dependent on the size of string. So that's why our space will be big O of 1. So I hope you got the approach and you understood the time and space complexity also. If you did, please don't forget to like and subscribe to Think Then Code. Have a nice day. See you in the next video.